6.1 Inverse circular functions. So recall that for a function f, every element x in the domain corresponds to one and only one element y of f of x in the range. If a function is defined so that each range element is used only once, then it is called one-to-one function, meaning 1x to 1y. Inverse function. The inverse function of a one-to-one function f is defined by, so what this is saying is that you switch your x and your y. So meaning you replace f of x with y and interchange x and y, solve for y, replace y with our implicit form of an inverse. You can read more about inverses, I'm sure you remember them, but if not, there's more information here for you. Alright, inverse sine function. So we can say we have the inverse of sine with that little implicit -1 form right there, or we can also say arc sine. So if you see arc, that just means the inverse of sine. The domain of the arc sine is the same as the y, because the opposite of x is y. So the domain for our arc sine is -pi/2 to pi/2. So you want to think of arc sine as y is the number or angle in the interval whose sine is x. And remember that this is what a normal sine function looks like. So the inverse sine function, I'm supposed to say function, is increasing on its domain -1 to 1. Its x-intercept is 0. Same with the y-intercept. It's odd. And for all x in the inverse, you have negative the function. So let's find y in each equation, meaning we want to figure out how can we solve for y. So obviously arc sine, or the inverse of sine, that's not really on the unit circle, because you're thinking if you flip it, that's not the inverse. Flipping a number is the reciprocal. So the thing we need to do is just get sine by itself. So you kind of move it over. You don't divide it, but you move it over to the other side, and when you do, it just becomes sine. Because if you have inverse of sine on one side, if you move it to the other side, it gets rid of that inverse of sine. So we have sine y equals 1/2. So now we're going to use the unit circle, UC is unit circle, to find where sine equals 1/2. So if you go to the unit circle, you'll see that pi/6 for sine equals 1/2. Because remember, sine is the y value, so you want the y value, and where it matches up is pi/2. Just remember that sine range, which is technically the domain of arc sine, is -pi/2 to pi/2. So we want to be looking with values in between that range. Alright, let's do the same thing here. So we're going to kind of move it over in a sense. So we have sine y equals -1. So if you're looking at the unit circle, sine equals -1 is 3 pi/2, but that doesn't support the range. The range is -pi/2 to pi/2. So let's find another value where sine equals just a 1. So let's find another value where sine equals positive and negative 1. You see it's at pi over 2. That supports our domain, but pi over 2 equals 1. Sorry, my Bixby went off. Wow, you know how your Siri goes off. Alright, so since it equals positive 1, we don't need a positive 1, we need a negative 1. So all we need to do is just switch the signs, because that's all it is, right? We just need to switch the sign, so we just need to switch it to negative pi over 2. And that's our answer. So we have sine negative pi over 2 equals negative 1. Alright, let's figure out the inverse of sine negative 2. So we're going to kind of, like, as we say, move it over. Negative 2. Is that okay for our sine function? Nope. Because what we're given is an x value. Oh, my bad. Let me change that color. What we're given is an x value. So we're saying x equals negative 2, but that doesn't support the domain of sine function. So there is no solution, but why? It's because x equals negative 2, that's not in the domain. Alright, be certain that the number given for an inverse function value is in the range of the particular inverse function being considered. So you know in part B how we had to be careful because what we originally thought of wasn't in the range? That's what we're talking about, so just be careful. Alright, so we have our inverse cosine function, inverse tangent function, and we also have the inverse of those reciprocals, so inverse cotangent, inverse secant, and inverse cosecant. So here's that chart again of all the important information, okay? I would use this chart when you're doing your homework. Alright, let's find y in each of them. So we want to do arc cosine 1, meaning we want to do the inverse of cosine. So just like before, we kind of, as we say, move it over. So we have cosine y equals 1. Use the unit circle, y equals 0. So we have cosine 0 equal 1. And let's remember for cosine that our range is 0 to pi. So whatever y we're finding, it should fit in that range, and it does. Alright, let's go ahead and... Oh, I forgot the y part. There we go. Let's go ahead, as we say, move it over. So we have negative square root of 2 over 2 equals cosine y. Now use your unit circle. Go ahead and figure out where cosine equals negative square root of 2 over 2. And we get it at y equals 3 pi over 4. So at 3 pi over 4, our cosine value is negative 2 square root of 2. So that means cosine 3 pi over 4 equals y. Oh, I know it. My bad. Equals negative square root of 2 over 2. There we go. That's why I paused. I knew that was wrong. Alright. Our arctan and secant. What the heck? Okay. So for arctan, let's remember that our range is negative 90 to 90, or negative pi over 2 to pi over 2. So just as a reminder, that's quadrant 4 and quadrant 1. So let's kind of move it over. We have tangent theta equals 1. So use your unit circle and figure out where, remember, tangent is sine over cosine. So go ahead and use your unit circle in quadrant 4 or quadrant 1 to figure out where it would equal 1. And you're going to be looking in quadrant 1. So tangent 45 degrees equals 1. Because it's square root of 2 over 2 all over square root of 2 over 2. That's why it equals 1. Alright, for our secant, our range is in quadrant 1 and quadrant 2. So we want to be looking for values in those two quadrants. So let's move it over. We'll have secant theta equals 2. And remember, secant is 1 over cosine. So we want to look for a 1 over cosine that equals 2. If you look at 60 degrees, 60 degrees is 1/2. So we have 1 over 1/2, which is positive 2. So our answer is secant 60 degrees equals 2. I got all of that information from the unit circle. Alright, we could also use our calculator to find inverse function values, so finding in radians and degrees. So for radians, if we wanted to find cosecant, the inverse of cosecant -3, remember that the inverse of cosecant, that's not on the calculator, or cosecant's not on the calculator, but we know that the reciprocal of cosecant is sine, so we could do the inverse of sine and take the reciprocal, so -1/3, and we get our radian value. And then for degrees in degree mode, if we want to find arc cotangent, remember the reciprocal of cotangent is tangent, so we have to use the inverse of tangent. And the reason why we add the 180, it's because we have cotangent must be in quadrant 2. So to get it into quadrant 2, we add 180. You're going to usually do that to your tangent and cotangents. So be careful when using a calculator to evaluate the inverse of cotangent of a negative quantity. Enter the inverse tangent of the reciprocal of a negative quantity in quadrant 4. Since inverse cotangent is negative in quadrant 2, you adjust the result by adding 180 or pi accordingly. And that's all because it was negative. Alright, back to triangles. I know it's been we kind of talked a little bit about it in the previous video with triangles. We haven't talked about triangles in a long time. So we're actually going to bring out triangles again, and that's going to be a theme for the rest of the semester. We're going to be drawing triangles again. So hope you're happy about that. Alright, finding function values using definitions of trigonometric functions. We're going to find the following without a calculator. So what part A is asking, it wants the sine of the inverse of tangent 3 over 2. So whatever the inverse of tangent 3 over 2 is, I want the sine of that function. Alright, I know since this is positive tangent, we're in quadrant 1. So I'm going to draw quadrant 1. And how do I know that? Because remember, we kind of move it over. We'll have tangent y equals 3 over 2. So that's how I know it's in quadrant 1. So I'm going to draw quadrant 1. And our triangle. So remember, tangent is opposite over adjacent. So opposite the theta is 3. Adjacent is 2. You can find this value right here using the Pythagorean Theorem. So we have 2 squared plus 3 squared equals c squared. So 4 plus 9 equals c squared. 13 equals c squared. So we get the square root of 13. Remember, to find any missing side, use the Pythagorean Theorem. So now it's asking for the sine of this function, or the sine of this triangle. So sine theta equals, sine is opposite over hypotenuse, so opposite is 3. Hypotenuse is square root of 13. We simplify, so 3 square root of 13 over 13. So as I said before, the question is asking for the sine of the given tangent function. All right, part B. So we want the tangent of whatever the inverse of cosine negative 5 over 13 is. Alright, so we have our inverse of cosine. We're going to switch that so it's not the inverse. So we have cosine theta equals negative 5 over 13. And since it's negative, we're working in quadrant 2. Remember, when cosine is negative, you're working in Q2. So let's draw Q2. And our angle coming out of that. Let's finish our triangle. Alright, remember cosine is adjacent over hypotenuse, so adjacent is negative 5, hypotenuse is 13, and it's negative 5 because it's left on the x's. To find our missing side, you use the Pythagorean Theorem, and it's 12. You know how to use the Pythagorean Theorem. You know how to find the missing side of a triangle, so I'm not going to show you, but we just use the Pythagorean Theorem to find any missing side. So now I want the tangent of this function. So tangent theta is opposite, which is 12, over hypotenuse. Opposite over adjacent, which is negative 5. So we have tangent theta equals negative the whole fraction, 12 over 5. You're going to hear my dogs bark. It's okay. Alright, let's find function values using identities. This is where it gets real fun. So we want the cosine of whatever arctangent square root of 3 plus arc sine 1/3 is. So the first thing we're going to do is just talk about the parentheses, and then we'll figure out whatever cosine means. So we have cosine blank plus blank, a plus b. So we actually have cosine a plus b, which equals cosine a, cosine b, plus or minus, for cosine, remember it's opposite, so minus sine a sine b. So we have to, I can move this over. We have to figure out all those values. We have to figure out what's cosine A, what's cosine B, what's sine A, what's sine B. So we have two triangles. We have the A triangle, and we have the B triangle. So our A triangle is arctan square root of 3. So all that is just tangent theta equals square root of 3 over 1. So since it's positive tangent, we're working on quadrant 1. And for quadrant 1 positive, we have opposite over adjacent, so square root of 3 over 1. And we need to find that missing side, the hypotenuse. Anytime you need to find a missing side, you use the Pythagorean Theorem. So we get 2. Also, if you have 1 and 3, square root of 3, you always have 2. Alright, now we have to do our B triangle. So our B triangle is sine theta equals 1 over 3. So since sine is positive, we're in quadrant 1. Let's go ahead and do our angle with our triangle. So sine is opposite over hypotenuse, so 1 and 3. Now we find our missing side, use the Pythagorean Theorem. It's 2 square root of 2. So now we can go ahead and find all of these values. We can find what cosine A is, cosine B, sine A, sine B. So cosine A, that's going to come from the A triangle. So cosine A, adjacent over hypotenuse, that's 1/2. Then we have cosine B, so adjacent over hypotenuse, that's our adjacent over hypotenuse. So 2 square root of 2 over 3. And then minus sine A. So we're going to be looking at our A function and finding sine of it. So sine, we have opposite over hypotenuse, square root of 3 over 2. And then we need to do our sine B function. So looking at our B triangle, let's do our sine. So opposite over hypotenuse, or 1/3. Let's go ahead and simplify this. So we have, excuse my dogs, 2 square root of 2 over 6 minus square root of 3 over 6. We don't simplify here. We just keep going. So since they have the same denominator, we have 2 square root of 2 minus 3 all over 6. So the cosine on the outside was just telling us, since we have blank plus blank, we want to do the cosine sum identity. Alright, so for part B, you're going to use a double angle identity. Why double? Because it has 2 and then something. So I highly suggest that through these videos, you're pausing and doing examples on your own, and then coming back to see if you did it right. Alrighty, part B. So for part B, we have our function, just our normal function, sine theta equals 2/5. So that's, since sine is positive, we're working in quadrant 1. So the first thing we're always going to do is draw our triangle. So we're in quadrant 1. And since it's sine, we have opposite over hypotenuse. So 2, 5. To find the missing side, use your Pythagorean Theorem. It's square root of 21. Okay, now since we have tangent and that too, since we have that, we know we have a double angle identity for tangent. So we're going to use tangent to, it could be B, A, theta, it doesn't matter. I just used B, I don't know why. Equals 2 tan B over 1 minus tan squared B. So what we need to do is find what tangent B is. So using our handy dandy triangle, we can figure out our tangent B. So opposite over adjacent, so 2 over square root of 21. You're going to notice something. I'm not going to even simplify this. I'm just going to leave it as is and plug it in. So we have 2 tangent B, which is 2 square root of 21. And that's over 1 minus tangent B squared. Alright, now we're going to simplify. So we have 2 times 2, which is 4, over square root of 21, all over 1 minus, so 2 squared is 4, square root of 21 squared is 21. Keep simplifying, we can simplify the bottom. So we have 21 over 21 minus 4 over 21, which is 17 over 21. I need to rationalize my denominator on top. So we have 4 square root of 21 over 21, all over 17 over 21. We can cancel out those 21s. So our final answer is 4 square root of 21 over 17. Alright, writing function values in terms of u. So let's write sine inverse of tangent u and as an algebraic expression in u. Okay, this is something that might be like super new to you. It's called u substitution. It's supposed to be taught way back in intermediate algebra, but I don't think they do it anymore. So it's really part of algebra 2. So if you don't understand what u substitution is, definitely take 10 minutes and look it up, u substitution in algebra, and then come back to this. So let's use u substitution. We have our theta. So we're going to let theta equals the inverse of tangent u. And then we're going to do what we have always been doing, move it over. So we have tangent theta equals u. Because we're working with the inverse of tangent, we're going to be working in quadrant 1 and quadrant 4. So I'm actually going to draw quadrant 1 and quadrant 4 together. Okay, cool. We have two angles coming out because we don't know where any of this is. It's just u. Well, technically u over 1. We don't know where any of this is. It's just u. But we know inverse of tangent can only be found in quadrant 1 and quadrant 4. So we have our two quadrants and our two angles coming out of them. We finish our triangles as if we normally do. And since we have tangent, we have opposite over adjacent. So u and adjacent is 1. They both share 1. And then here, u on this side right here, isn't that where the y value would be? The u, because it's going up and down. So that means u, it has to be positive. Here, u has to be negative because it's going down. See how it's going down? So u is negative. So let's find our hypotenuse for each of these. So for find our hypotenuse, we have 1 squared plus u squared equals c squared. So 1 plus u squared equals c squared. That means our hypotenuse is the square root of 1 plus u squared equals the hypotenuse. And it's positive because it's the hypotenuse. Remember, hypotenuse is always positive because it's a distance. So now let's find the sine of this function. So we want to find sine theta. So we have opposite, which is u, over hypotenuse, which is 1 plus u squared. Let's simplify this. So we have u times the square root of 1 plus u squared, all over 1 plus u squared. So the result is positive when u is positive. The result is negative when u is negative. Alrighty. The optimal angle of elevation theta that a shot putter should aim for in order to throw the greatest distance depends on the velocity v of the throw and the initial height h of the shot. One model for theta that achieves this greatest distance is theta equals arc sine the square root of v squared over 2v squared plus 64h. Suppose a shot putter can consistently throw the steel ball with height equals 6.6 feet and velocity equals 42 feet per second, at what angle should he release the ball to maximize distance? Alright, we're given h and we're given v. Let's plug it into our formula. So we have theta equals arc sine square root v squared, so 42 squared, over 2v squared, so 242 squared, plus 64h, and h is 6.6. Plug this into your calculator, and you will get theta equals arc sine 0.6682342849. Make sure you're in degree mode. Why do I know I'm in degree mode? Because it says theta. That's all. It says theta. Theta, remember, implies degrees. So in degree mode, we can solve this by using the inverse. So, because remember that this just means inverse. So we have theta equals the inverse of sine. We put that in there. And you should get theta is approximately 41.930939, and theta is about 42 degrees. To get inverse of sine, if you want to get this on your calculator, press second sine and you'll get it. Make sure you're in degree mode.